Hello, everyone. Welcome to my talk. My name is Mathew Benson. I'm going to be speaking about C++ in the developing world and why I think it matters. First, a little bit about me. First thing you should know about me is that I really like C++. And I expect that if you are at this conference, I presume that you do. Or if you'll be watching this later, I presume that you like it or are at least curious about this language. I am a graduate computer scientist. I've been working with computers for quite a long time, personally. And just something that I live and breathe in my life every day. I'm particularly passionate about energy efficient computing and making the most out of all the hardware, just making the most of what is available. So here are my contacts. I'm Benson Lorena on Twitter, Mathew Benson on the hackydam.io server. Here's my email, GitHub. I generally do hang out on the CPP Africa Discord server. So, what are we going to be talking about today? It's not going to be a code-heavy talk. It's a talk that is birthed out of like my musings and my thoughts after such a long time programming and dealing with all manner of technologies. And in this journey, I've come to find that I really feel I have very strong feelings for C++, and I'd like to explore why I think it's a very important language, especially to breathe new life into older hardware, which ideally is more accessible in the less developed world. I'll also be looking at C++ as a platform for learning how to program, why I think it's an important language to consider learning about. If you're a student and you're thinking which language should you apply yourself to, I'll touch a little bit on that. I'll also touch a little bit about some tooling and some resources that I think would help in this journey. As an alternative agenda, the very least, I hope to address this new development with the White House urging developers to dump C and C++. I don't so mind them urging us to dump C. It's the C++ I hope to respectfully disagree with, and hopefully prove them wrong, or at the very least start a conversation that will drive or change this trend. So, as we get started, to set the stage for what I'll be talking about, I'd like to go through some definitions. The first definition is C++. I've been thinking about this a lot. In fact, I've given this talk before, and at this point, I've generally quipped that it may be a silly thing to describe what C++ is at a C++ conference. But I think this term is not quite understood as well as it should be. And as I was preparing for this talk, I made a mental note to myself to really try to discuss this and to try and start a lot more discussion to really define what exactly C++ is. But in order to do that, in order to actually to answer this question, it's very difficult to do this without first talking about C. It is indeed the first letter in C++. So, as many of you know, there is a language called C. C came before C++. It's a much older language. And C++ was an evolution of C. And I view this as a journey. something that we know we must remember, like when you go on a long trip, when you're engaging in a long task, from time to time, you need to take a break and think about where you've come from, as well as where you're going, to remind yourself, especially when the journey gets hard or you can't see where you're coming from or where you're going. But C is a low-level language. Quite low, but in its time, it was described as a high-level language, where we'd use words to describe concepts of lower-level things. But, and I'm referring, of course, to assembly, or the machine language, so to speak. So C was a necessary step up from assembly. And now C++ is also a necessary step up from C, born out of a need to better express programming intent, especially as tasks get more complicated. C helped us to work with low-level constructs like memory and pointers, but to use words to describe these things. As we move on, I think the second part of C++, the plus, I think is very, very important to kind of like dissect. Many of us know that the language C++ was originally called C with classes. And it embodies the introduction of types to wrap the lower level concepts, to hide the pointers and the raw memory access in a much safer way, to create these abstractions, or to allow us to create the abstractions as developers. But it's the continuous development, the plus step. Many of you know it. It's symbolic of the plus one operator, so to speak. We're adding by one step at a time. And I feel very strongly that this is the core of this language, a language that has improved over time, one step at a time, and continues to do so. But to be very, very clear, C++ is not C. I say this because I feel not enough people know this distinction. Yes, C does have its roots in C. It is compatible with C. But there is no language called C/C++. It is an independent language. So the next thing I'd like to talk about and to describe is the developing world. The common definition of the developing world, usually in the perspective of countries, or countries that are perceived to be of lower income levels and with less access to money. I'd like to take a slightly different trajectory as I explore this. And as we go ahead to do this, let's first discuss what it means to be developed, especially in terms of computing. Generally, it means to have enough or more than enough. You're comfortable, enough cores, memory, as much as you can afford. It's at your fingertips. To be connected at a good speed, gigabit, fiber, good connection. Just instant, whatever you want, you can get it almost instantly. Of course, there's no computing without power, but you do need to be able to have uninterrupted power. No brownouts, no blackouts, just power when you need it. And to have uninterrupted connectivity. This is slightly different to having slow internet. You can have good quality but slow connection, or you can have a very fast connection, but it's intermittent. It's here today, gone tomorrow. But to be developed is to not have to worry about any of these things. And very importantly, to be developed means to have the knowledge to make the most out of it, to have the skill to make the most of what you have. And generally, when we're in a developed situation, all this is affordable. It's at a cost you're able to pay. However, on the other hand, developing is the process of growing closer or moving towards that ideal and comfortable situation. So in terms of computing, I would describe developing as lacking in any one of those other areas. For example, you could have the most powerful computers, but without electricity, you have nothing. Or you have it intermittently. When you need it, sometimes you need it, it's not there or not there. I refer to that as developing. You may have all of that, but not enough power, not enough juice, so to speak. You're working on your laptop and you're trying to compile large programs. You don't have enough power to last you as long as you'd want. So as we also talk about C++, especially the plus plus, I wanted to use this word developing loosely to describe that continuous process of growth. Things are not stagnant, things are growing continuously. So developing, while my emphasis is any person just who is not in that comfortable situation, any person, group, region, etc. And I feel that in reality, there are very few places that have that ideal developed experience. This could be our data centers, where there's backup power and high-speed internet and the like, or our cities. But the farther you get away from the cities and the data center, you start lacking some of these comforts, so to speak, of the developed world. So it's in these areas where you're lacking in one way or the other, and you really need the sensitivity of performance is really felt. And on top of that, a large population, a large number of people don't have that comfortable access. They either live too far, or even if you live within the city, you're in an area of the city that perhaps doesn't have certain facilities. There's too large a number of people who don't have that access. And the only way we can bridge that gap is to lower the cost of computing in general. So, to lower the cost, we're talking about accessibility. We're trying to make sure people are able to access computing, information, and the like. And a phenomenon that has happened over time is that technology gets smaller and smaller, meaning it costs less to run, it uses less power. As an offshoot of that, it's now possible to do the same task with less power, meaning within the same power envelope, what used to be a 2-core computer can now be an 8-core computer. Or it may mean that we can do a lot more with the same level of computing. The 2-core computer of a few years ago may not have been able to last as long as a 2-core computer today. So the cost of hardware, the cost of like what cost a lot, say 5-10 years ago, does cost a lot less because newer things pushes down the cost of the older things. So that means that the lower cost hardware is generally older or slower hardware. So onto the heart of this talk. Talking about C++ for writing efficient code for older hardware, where I feel it matters. Because computers are very expensive. A great computing experience is very expensive, can be very expensive. A large population of the world really struggles to meet this expense. So there have been efforts to bridge this gap. And there are a few ways that has happened. One of the ways is that computers have changed the form in which they come in. Mobile phones have been very revolutionary in this regard. What we would call a computer, desktop computer, the beige boxes of, say, 20 years ago, have the same power as what is in your pocket. Another way is, as I've alluded to, the computers, the older computers, like what would be termed as obsolete, finds its way into the developing world because its cost has been reduced. And a third way is that even manufacturers do tend to repackage their older offerings as new budget offerings. But in light of all of this, a lot of code is written with today's current hardware in mind. I'll touch briefly on Chromebooks, which in some places has been is considered to be a low-cost option. But I think it only is low cost if you have access to the internet. But many places that don't have that access, it doesn't work quite as well. So I don't quite consider the web-based solution to be ideal, especially for places where the connectivity is not, say, the best. Mobile phones do have great potential, but the software is very different from our laptops and our PCs. So I think software has a great role to play in bridging this gap. Because many of the people what is accessible to most people will generally be either underpowered or very, very power inefficient. So performance of software is critical to bridge that gap. And this is what I feel is, this performance is very important for us to consider, to put first on the list rather than security. Though I do agree and understand that we do need security, especially with this in the online world, but it should not come at the expense of performance. I think in the developing world, performance comes first. And in addition to that, there's also the matter of scale, because with better software, it's possible to deploy to a larger number of people, even using less hardware, so to speak. So the software performance is really, really important. And there are projects that wouldn't even get off the ground if the cost doesn't make sense. So just as an aside, as hardware has also evolved, gotten smaller, uses less energy, our software also takes time to catch up. And it's something that we see even in our language. There are things that are proposed, but it takes time before it waters down to our compilers and into the hands of real people. And there are optimizations that may not have existed before, say when a certain generation of hardware was first used. But with time, if you apply the right software or if you apply those optimizations, all the hardware can do things that we may not have thought of before. So just to touch briefly about why I think C++ and I'll touch on the native language are very, very important. We must always think and consider that a large portion of our potential users may not necessarily be using what we have access to, say as developers or in the corporate world. That the regular person needs performance, but at a very low cost. And I think that the cost of using a browser or managed languages may be too high. I've had personal experience with this, where there's a computer that I had, I still have, and use from time to time, and I have seen the difference between running something natively, say playing a video natively, a YouTube video, versus playing it on the browser. Like playing it on there is a performance penalty that can be very heavy. But playing it natively, perfect. So as we develop on our high-end machines, we may not feel the difference, and even may consider that, may argue that our computers are so fast, so we don't really need to think about performance. But I think we need to think about our users, and especially like users who may not necessarily have a big voice, so to speak. So I'll say it again. I think in the developing world, performance matters a lot more than safety. So I'll touch on a few features of C++ as I see it, why I think it's the better language, so to speak, for me and possibly for you. I love what it's designed to do. I love how it is, it factors in C, but hides or wraps the dangerous parts of C and presents it in a safer way. But always keep in mind of the cost of what it takes to do the computing, so to speak. I like that it is stack-based, meaning that there's nothing kind of like between me and the hardware, but still safe, knowing when I'm deleting and not waiting for something to be deleted somewhere in the background. With constructs like vector, which are safe or safer than working with pointers, I like the control. And I've seen in code that I've tinkered with here and there that it's easier to use to extract kind of like a bit more performance in a safe way, with peace of mind, so to speak. So one of the core reasons why I think now the native approach, especially the native approach of C++, is really important, is what it affords us at compile time. How much more we're able to compute once and not have to repeat on the client computers. So the more that is done at compile time means that whatever we ship, that computing doesn't have to be done over and over again, which is something that I have found with managed languages. So there's a constants and the context for support and just constructs that are meant to ensure the safety at compile time. Basically, on our computers as developers, and we get to ship safe code but native code and kind of like slimmed down code, because most of the computation can be done in advance, meaning we get to have more performant software where it's really needed. It's also we also have constructs, especially for structuring our code properly for parallelization. And I think we don't take as much advantage of especially the parallel facilities, the extra cores that our computers have. A lot of code still is single threaded. But of course, doing this is very difficult. So we need better ways to communicate with our hardware, with each other as developers, in order to take advantage of the parallel computing that is available. So these are the reasons why I think that C++ is a relevant step up from C. I don't think we can deny the benefits of C. Its performance, the ABI, the ability to extract maximum performance. This is what runs our kernels. This is what runs the core parts of our programs. But in order to take advantage of that, I think speaking in a similar language, but a safe language, is a better way forward. And there's a lot of code written in C. And to kind of like advance or to take advantage of that, I think it's always better to kind of like speak the same language and to be able to kind of like improve step by step the plus plus. Because yes, there are large code bases in C. But because of the compatibility with C++, it's possible to, wrap a function here, class, create a class there, and kind of like just encapsulate things bit by bit. Because it is a very complex thing. Software is very, very complex. The effort that has gone into our software over the years is very complex. And I feel that having a similar language to kind of like step, just one step at a time, improve our code is the better way to go. And I think still to date, it's still the better way to access most of the features from our operating system, which are exposed as C functions. But it's the language, the same language. It's possible to just wrap this operating system functionality without too much in between and just get the job done. So I think these important libraries, the OpenGLs, Vulkan, Direct3D, they all C level constructs, but C++ is the way to kind of like wrap that functionality and create abstractions that are better able to express what we really, really want to do with our computers. So, in light of that, I'd like to talk about a little bit about learning/teaching C++ based on my experience. I'm not a teacher, But I'd just like to speak as someone who has learned and read many books, seen different kinds of resources, and I'd just like to speak on my experience and how I feel. Perhaps we can be able to solve the problem of communicating this complexity in the best way possible. Well, one of the first things about our languages, of this programming language, is that it's supposed to be about communication. But our humanity is very diverse. We are very, very different. Even people from the same family are different. We have different interests, talents, and the like. So this diversity is kind of like an obstacle to communication. But our languages are meant to bridge that gap. And because of this, how we approach the language is very mixed because of different reasons. But we still need to get the point across. So I'd like to kind of like use human language as an analogy to learning C++. It is just language after all. And according to the FAQ section on the website for the American Linguistic Association, there's an FAQ section and it talks about how children learn how to speak. How do we acquire language, even the language that we speak in our day-to-day communication? And a few takeaways from that article is that when children are born, they have a natural ability to pick up language, usually the language that they interact with first. So we acquire language by interaction with the language, especially as children. And we do so as we talk with the adults and with other children. The process is the same, and there are certain distinct stages on how that language is learned. It's gradual and step by step. And the adults do help to improve the learning of children by, kind of like stretching down a little bit using so-called baby talk. You step down to the level of the child and you kind of like help them, you bring them up to your level. So I was thinking about this in terms of C++. Our human interaction is very crucial to, communicating and teaching it, and also making sure that the world also sees the language as what it really is. This is what has brought us together in this conference. Our user groups, many Discord servers. The more we speak about code, interact with it, read it, talk about it, the better we get, and the better we're able to make use of what we have. So it's not perfect. And as with many things in life, many people do various things for different reasons, different for each individual. We have very different starting points. And so, in light of that, I want to kind of like encourage anyone who is learning to always just keep in mind that it's just a language. And even those who do use the language, to compare it even with the real life languages. Our languages are not necessarily perfect. They serve the purpose of communicating, but they also do have variations just depending on various reasons, our accents, the way we speak, the way we pronounce things. So it's very important to be very mindful or where other people are coming from. Even as you're reading somebody else's code, they may not think exactly the way that you do. But these, I feel an innate intelligence within us to empathize, to be more careful or conscious, so to speak, as we interact with our code, as we speak about code with other people. Just generally, as we interact, as we do in real life, we should be able to do the same with our code. So, as we're trying to learn, there's no one-size-fits-all solution. There are many different teachers, books, resources, techniques, because people are coming from very different places. So, I say this to encourage anyone who is having trouble learning that, perhaps you may just need a different teacher. You may need a different kind of like resource, so to speak. What may have worked for somebody else may not work for you, but try as much as you can. Read as many resources as you can. And try and find that fit, that teacher who kind of like meets what you need. We're all learning, even some of our experts are still learning, keeping or discovering new things every day. And I feel that as long as we approach it in that human way, understanding that, yes, it is a big task to learn a language, but it's a worthwhile task if we put the effort into it. So a very core thing, especially with C++, is that it's very, I feel, honest about where it's coming from. It is C++. It does acknowledge where it has come from. And it's talking about plus, like this, going somewhere, so to speak. And this is something that I feel is very important to keep in mind. You have to keep on reminding yourself. Where are we coming from and where are we going? And that's one of the core strengths I find with C++. It is also, unfortunately, one of its weaknesses, because I think this compatibility is what makes people confuse or not be able to tell the difference between C and C++. But I feel the story as a whole is a very beautiful one. There's a lot of history. And I like to compare it to, the kind of story that wouldn't fit in a single movie. But you have like a series of 4 or 5 movies that tell this beautiful story, bits and pieces. So the core point basically that I'm trying to get across is that it's very important to keep in mind that this programming is very complex because it is something that has evolved over a long time. And so the journey of 1,000 miles begins with a single step. As we take our steps towards learning, I feel it's important to keep on reminding yourself why you're learning and to keep a reference close at hand, to keep like a map, especially when you're new. Like if you go to a city first time or just a new place, you find you rely on the map a lot more. You need to have like a guide, to kind of like show you the ropes until you kind of like get comfortable. So the heart of the C++ is the plus part of it. I know I've repeated that point severally, but I feel it's an important one. So I'd just like to touch briefly just on a few resources and tips of what I feel is important to keep in mind as you try to learn and work with this language. I'll start with a favorite learning resource, cppreference.com. And the main reason why I'm doing this is also to emphasize something that kind of came to my attention about the cost of learning. There are good learning resources, but they do cost. We do have trainers. We do have people who have written books, but not everybody has that luxury. I personally actually did a lot of my learning using free resources. And generally, just whatever you're learning, one of the best places to look is kind of like the manufacturer's documentation, like the resource that the person that made the software has made available. It's generally free because they want to encourage you to use the software. For C++, that happens to be the cppreference.com website. There are others, but I'll kind of like focus on that for now. When you load it up, looks very complicated, but I'll isolate the top left corner, the language. To start from there, when you go to the language section, many terms presented to you, but there's a section, basic concepts, the top left corner again. This is a page that I think this is a good place to start with, especially when you're starting to learn, or even if you've been learning, it's good to actually have this open all the time, because you need to, kind of like see the picture as you're working with code, even as you're reading, as you're just working with C++, especially the distinction between headers and source files and declarations and the like. This is a good place to keep this open in a tab, print it out, just have this as a guide and go through it slowly, especially the highlighted sections, the declarations, translation, main function. It's important to explore these words slowly, patiently. Use a dictionary if English is a problem, but just get to know the heart of what is going on. There is also a section in the MSDN documentation. They actually have a very good documentation on C++. This is what the site looks like. And right at the bottom left, there's a section there where you can download it. You can literally download the entire site and save it on your phone. Just read through it slowly and patiently. And make sure to master, especially just the terms, to understand what's being talked about. The reason why I've gone through the whole of this is to emphasize that you need to understand the language so that when you attend a talk and you hear somebody talking about an expression, statement, variable, you're kind of like now able to move to the next level, but you need to have the foundation of the language. So I would encourage just about everyone to really, take the time to know the terms very, very well, to make it easier to understand what's being said when you buy a book, when you watch a talk, and etc. Just touch briefly on some of the things that I've learned dealing with older hardware or in constrained computing situations, especially when it comes to learning. And so I start that, I just want to just emphasize that, you see, to boost or to make available more computing to more people, there has to be access. There must be access to computers, power, books, connectivity, and the like. And it's very important to, even as you start your journey, to crawl before you walk and to walk before you run. And in this regard, it's important to look to the past a little, especially in terms of software, because there is a tendency for software to catch up with the hardware, and they but there are some older software packages that, if applied well, can really do great things even with older hardware. And as you learn how to program, I would like to suggest that we don't start with the integrated development environments. It may be cheaper and more effective to just start with the basics: text editor, compiler, to get to know what's going on. Because the IDEs are very good for high performance environments, but they have too much, there's almost like too much going on the screen for just somebody who just needs to understand simple concepts, so to speak. So when you're starting to program, it's my proposal or my suggestion that you don't start with the IDEs, but start with the terminal, text editor. And if you don't know what those are, search about it. Search on it, research about it. Get to know where the computing is coming from, because this is how programs used to be written. This is how computing used to be done. And it's a foundation upon which even the IDEs that I mentioned earlier are actually built upon. And when you understand this, then you're better placed to make the most out of it, out of the IDEs, so to speak. And this model, I feel, is very cost effective and is able to create scenarios of teaching more people, especially when there's less resources. As an aside, it's important to learn about the shell, be it Bash or PowerShell. Learn how to use the shell and commands and command flags and the like. So for scenarios where you may not have such good connectivity, it's always good to keep as much as you can locally, be it books, websites. There is a way to download the entire cppreference.com website. It is even available as a package on some Linux distributions. So the more you have within your reach, so to speak, then the better you're able to learn and spend your free time catching up on the language. And when you can afford to, if you can afford to, sign up to good courses, buy good books. If you search, you kind of like get a feel for what would be the recommended selection, so to speak. And on the same vein of keeping things as local as possible, if possible, if you're in a situation where there's a network, keep things on the local network. It's possible even to have, like a local compiler explorer to rely kind of like on what is on your computer as much as possible, and to remove the variable of intermittent connection, so to speak. Now, in the same vein of using the terminal and terminal-based computing, there are opportunities that are opened up, especially with the Secure Shell Host, SSH, something that I've been working with. In fact, personally, I do use NeoVim, both on Windows and Linux. And I get to be able to, kind of like work on multiple machines from one place. But this same analogy can be split differently, because if you're looking at a situation where you're trying to, they're limited computers, maybe they're many mobile phones. Mobile phones are much cheaper. and you're trying to share that computing resource, it is possible, even on Windows, to have a multi-user computing experience where you have, cheaper terminals logging into a more powerful computer, running Compiler Explorer, or just even each user having their own session. So it's something that can multiply what we're able to do, even with the little that we have. Another reason why I was kind of like alluding to avoiding the IDEs, especially initially. And as you get better and you're able to afford it, then yes, all invest in the powerful computers, invest in the IDEs, and off you go. So, in conclusion, I propose and I kind of like, as a takeaway, feel that C++ is one of the most important languages that we have because of the way technologies where we have come from, because of the attempts to evolve what we have. And we need to talk about it more. We need to, I guess, preach it more, so to speak, especially in this environment where there's a message coming very strongly that, to do away with this kind of language. We do need the performance benefits of C++ applied to where it matters most, extending the life of older hardware, making it cheaper, and therefore making it more accessible to more people. Some older tooling and software may still be very relevant to advancing this goal, making it possible for more people to have access to computers, even if those computers may not be able to run, kind of like the modern environments. The terminal is still something that we shouldn't kind of like disregard, so to speak. I feel it's still very important. So the personal computer can do so much more with better code. And as we continue to talk about code and improve performance, I hope that this kind of like gives, like a direction or gives some insight, to kind of like inspire better coding or just more experiments with what we can do with our software. So that's my talk. Thank you very much for listening. Thank you. Okay. Okay. Yes. I think it's something that we do see. I mean, it's something that if you walk around, even just consider the cost of computing and you look around at, kind of like people all around you, you see that, I mean, even if you go out right now to buy a computer, say, look at what you can find for, say, $100. Imagine how many people cannot afford that $100 for a computer. Like, the standard cost that most people would do pay for computers is, say, $1,000, $2,000. So when you look at the cost of what's available at the lower end, you kind of like see the problem a little bit clearer. And it's something that I feel is the population that does not have that access is too large.